welcome everybody. We are very happy to see you here at our virtual doctoral student and junior faculty consortium organized by the SMS Research Methods community. So my wonderful co-organizer is Anne Jacqueminet here with us.
Hello.
And yeah, Anne. And we have an absolutely fantastic panel with Olivier Chatain from HEC Paris, Richard Makadok from Ohio State University, and Claudio Panico from Bocconi. So again, we are very happy that they agreed to join us here today, and they are wonderful experts on formal models. So to put things in a perspective, the SMS Research Methods Community Consortium has actually 3 different sessions. We already had one session on Monday on natural language processing and machine learning with Raj Chaudhary, Ariana Marchetti, and Maciej Borkiewicz. And yesterday we had a session on the two-sided matching methods with Florence Honoré, Denise Mendruta, and Ori Shalev. And today is the final session on formal models. And actually, I think I already saw a bunch of participants who have been there both on Monday and Wednesday. So again, I hope you would enjoy the concluding session of the consortium. Now, so what we'll do today is we'll start with a panel. So again, we'll try to keep it to 1 hour, 15 minutes. We might get a bit overboard because again, we have wonderful experts here who have a lot of knowledge to share. So we'll start with Rich Makadok, who will tell us about why use formal models in strategy research. Then Claudio Panico will talk about how to evaluate formal models. And finally, Olivier Chatain will give us the editor's perspective on formal models, which again would be helpful to you thinking about how you should plan about writing and publishing formal model papers. After that, we'll have the Q&A, and after a little break, we'll have the breakout rooms. We have several people who already registered for the breakout rooms, and we have your preferences. Now, if you have not emailed us beforehand, but you would still like to stay for breakout rooms, please just message Anne privately. She will be assigning people to breakout rooms, and we think we can also accommodate you, or just hang out after the end of the Q&A. Yeah. In terms of questions, we'll use the same model like in the previous 2 sessions. So please write your questions in the chat. Again, we encourage people to start engaging with them in the chat during the panel. But after all 3 presentations, Anne and I would come back and we'll call on those questions and bring them to the common discussion. Okay, and we will also try to keep up with the panelists' presentations, and we'll try to post the references and the links to the papers there. You also, I think some of you should have received the reading list. We'll be happy to share it also later with those of you who registered a little bit closer to this day. There is a wonderful list of very useful references put together by our speakers. So anybody who is interested in formal models, that could be a good start. And I think with this, without much further ado, I'm going to stop talking and I will hand it over to Rich.
Thank you. Thank you, Elena. Let's see. Okay. Give me a thumbs up if you can see the screen. Okay. Can see my slides? Okay, very good. So I'm going to talk about why one might want to use formal models in the field of strategy. But I want to start with some thoughts that other people have given on this very same question. So back in 2009, AMR published a special issue on formal theory in management, and the 4 co-editors of the special issue, Ron Adner, Laszlo Poulos, Mike Ryle, and Olaf Sorensen, their introduction to the special issue was called "The Case for Formal Theory," and basically they say it's about rigor, precision, and having an audit trail on the logic of the theory. I'm going to partly disagree with that. I think this argument is kind of a red herring, perhaps a sideshow. Yes, formal modeling does add transparency and rigor, but I don't think that's its main benefit. I think if the only benefit of formal modeling were simply about improving the transparency and rigor, then I suspect it probably wouldn't have much influence at all. Formal modeling, like any research tool or method, I think is best judged according to the degree of insight, not the degree of precision that it brings to the field. This is true in, as well in empirical work, right? In empirical research, I can't think of any empirical researcher who has made an impact merely by finding techniques to reduce the amount of noise in the estimate of a regression parameter that's already been the subject of other previous studies. Only if that improved estimation technique generates results that are dramatically different than previous results or from expected results would the improved precision of an estimate matter very much. That is, only if the improved precision led to a valuable new insight. In that case, it would really be the insight that mattered, not the precision. So the impact of empirical work is proportionate to the degree of new insight, not really to the degree of precision. And I think the same is true in theory. And so, as an example, in empirical work, I was a student in Ned Bowman's strategy seminar at Wharton, and I remember reading his highly influential papers on the risk-return paradox and risk-seeking by troubled firms. Very influential, very path-breaking papers, but had very rudimentary, unsophisticated empirical methods, nothing more sophisticated than a correlation. And so I think that provides a great example on this point, that it's about the impact is about new insight, not about precision or rigor. And I think the same general principle is true of theoretical work as well. I can't think of any formal modeler who's made an impact merely by sharpening the precision of an existing verbal theory. A formal model really only has impact when it generates some valuable new insight. And so as with empirics, it's the insight that really matters, not the precision. So the relevant question should be, does formal modeling generate valuable new insights? If so, where and how? So that's what I'm going to talk about here. I'm aware of 3 common ways in which formal modeling can help a theorist generate new insights. Decompositions, interaction effects, and boundary conditions. And in a moment, I'll discuss each of these 3 in greater detail. But first, I want to make a comment about the word help. What do I mean by help deliver? I would never say that formal modeling is absolutely necessary for generating any particular theoretical insight, nor would I ever say that any particular insight could not be generated through verbal theorizing. Nevertheless, there are some kinds of theoretical insights that are just easier to see with the aid of a formal model. By analogy, it's like the difference between a hand tool and a power tool. At least in principle, you could chop down any tree with just an axe, but there certainly are some trees for which you would really much rather have a chainsaw as a matter of convenience. You can certainly survive without such a modern convenience, but why not use them if they're readily available? That's roughly how I think about formal modeling, just a helpful modern convenience. So let's talk about these 3 specific methods of generating insights and how formal models can help. Okay, I'm going to illustrate each of these methods with some famous examples from economics, as well as my own research and strategy. So let me start with decompositions. Decomposing an effect into separate parts that may sometimes oppose each other, such as direct and indirect effects or intended and unintended consequences, can lead to valuable insights. You can ask questions like, do these direct and indirect effects pull in the same direction or in opposite directions? And if they're pulling in opposite directions, when does one outweigh the other? For example, in economics, the effect of the change of a price of a good on the quantity of that good demanded is decomposed into two separate parts. There's the substitution effect, which is, I would say, a fairly direct effect, and the income effect, which is somewhat of an indirect effect. And in most situations, what economists call normal goods, these two components of the effect move in the same direction. But sometimes they move in opposite directions. And the example that economists use is what they call Giffen goods. And one empirical example is basic necessities that get into much higher demand when people's income drops. It's just easier to understand this kind of decomposition with the aid of a little math. I suppose one could possibly envision the possibility of a Giffen good without a formal model, but I imagine it would be a lot harder. So from the field of strategy, an example of this sort of decomposition is my own 2013 article with David Ross in SMJ, where we decompose the effect of product differentiation into two separate parts, a competitive advantage effect and a rivalry restraint effect. And sometimes these two parts move in the same direction, but sometimes they move in opposite directions. And the math of our model helps to clarify when each part is strengthened or weakened, when they oppose each other, and when one might overwhelm the other. Could these results have been generated through verbal theorizing? In principle, I suppose so, but I think it would have been a lot harder, and I certainly could not have done it. Okay, let me move on to the next category of insights, which is interaction effects. So it may be relatively easy to envision the main effect that X affects Y, but it may be a bit trickier to envision the interaction effects of how Z influences the strength of the effect of X on Y. Is the effect of X on Y dampened or undermined by when Z increases? Is it amplified or is it reinforced when Z increases? These are important questions, and a formal model can be quite helpful when answering such questions about interaction effects. Without a formal model, it may be difficult to develop a clear, unambiguous argument for why such interaction effects would be either positive or negative. Indeed, without a formal model, a theorist might never even think of the possibility that Z could have an effect on the relationship between X and Y. But such unanticipated interactions may just naturally drop out of a formal model without even looking for them. And in this regard, a formal model may even suggest new insights that the theorist had not previously contemplated. So let me give some examples. Again, an example from economics. Basic agency theoretic models in economics, such as Grossman and Hart's 1983 econometric article, focus on the main effect of performance-based incentives in terms of motivating behavior from an agent that is that's more consistent with the principal's interests, right? But how is this main effect altered when the agent's assigned tasks differ in their measurability, right? That's my Z here. And how does such an interaction effect influence the division of labor among different agents? So while a formal model might not be absolutely required to answer these interaction effect questions, the one that was developed by Holmstrom and Milgram in their 1991 Journal of Law, Economics, and Organization article, it sure helps a lot. Likewise, in the strategy field, I've used formal models to hypothesize interaction effects on the dependent variable of profit. So for example, my 2001 SMJ article finds there's a negative interaction effect between the profitability of information-based advantages and the profitability of deployment-based advantages. Likewise, my 2003 SMJ article finds a positive interaction effect between the profitability of skills and the profitability of motivation. And similarly, my 2010 management science article finds a negative interaction effect between the profitability of competitive advantage and the profitability of rivalry restraint. These interaction effects would have been difficult for me to envision without the assistance of a formal model. I suppose in principle, someone else might have been able to envision these results without a formal model, but I definitely could not have. Finally, third category is boundary conditions. So in extreme cases, if an interaction effect is particularly severe, it can completely overwhelm the main effect. For example, A may ordinarily increase B, but if A and C have a negative interaction effect on B, then it may be possible that a sufficiently large value of C may totally erase the effect of A on B, and perhaps even reverse what the ordinary effect of A on B would be, so that A actually decreases B. We often call this a boundary condition on the positive effect of A on B. That is, in this case, C must be sufficiently low. In this regard, as my friend Peter Klein has written, one benefit of formal model is, quote, bringing to light the hidden assumptions of the old-fashioned verbal models, insofar as a hidden assumption is just an unrecognized boundary condition. However, that's only half the story. A formal model's predictions, a formal model not only can identify the boundary condition, but it can also make predictions about what happens when the boundary condition gets violated. So in economics, there are many examples of such boundary conditions that have been identified through formal modeling. For example, the classic, Bertrand's classic response to Cournot oligopoly, the idea that just two firms can be sufficient to eliminate all profit from an industry if their behavior toward each other is sufficiently aggressive. Likewise, Akerlof's work on adverse selection creates a boundary condition on the ability of markets to improve welfare. Were the formal models absolutely essential to achieving these insights about boundary conditions? Maybe not, but they certainly help a lot. In the strategy field, a formal model by Luis Cabral and Miguel Villas-Boas in 2005 Management Science demonstrates a boundary condition on the idea that publicly available synergies would increase the profit of firms in an industry by showing that sometimes they can actually decrease firms' profits. And my 2016 SMJ paper, co-authored with Jens Schmidt and Thomas Kyle, takes this boundary condition one step further by showing that even private proprietary synergies can sometimes backfire and reduce profit. Now, I can't speak for Luis, Miguel, or my co-authors Jens and Thomas, but I know that I certainly could not have envisioned or anticipated this boundary condition without the tool of formal modeling. I'll just make a few closing comments here. I know I'm probably running long on time, but I'll say in terms of the impact of formal modeling on a field, like with any tool, there is diminishing marginal returns over time. After a century of using formal modeling in economics and finance, it's basically been overused there. There's economists and finance researchers are putting in a lot more and more effort for less and less insight over time. But it's while it's been overused in fields of economics and finance, formal modeling has been drastically underused in strategy. So there's still plenty of low-hanging fruit. You're really in the right place at the right time. A little modeling effort can still yield pretty big insights in the field of strategy. So I would encourage you to look for conventional wisdom that may not always be correct in all circumstances, and use that as the basis of formal models. So this is actually a graphic that I downloaded from the web that's supposed to illustrate procrastination, but I'm also using it here to illustrate where we are in the development of formal models in the field of strategy. So, here we were back in 1982 when Steve Lippman and Dick Rumelt published what really is the first formal modeling paper in the field of strategy, their uncertain imitability paper in what was then called the Bell Journal of Economics. And that's, was really what started formal modeling in the field of strategy. Over here, where we were just kind of getting started, I'll say that was around the time when I published my 2001 SMJ on integrating resource picking and capability building into a single model. Back in 2007, Adam Brandenberger and Gus Stewart developed this extremely helpful and now widely influential and widely used technique for formal modeling and strategy called biform games. So I would say that period of time up to where Brandenberger and Stewart published that was really the uphill push, getting to the top of the mountain. You're here. You're at a point where, it's becoming a series of small tasks where you can apply existing tools and it gets easier and easier. So I think you're in the right place at the right time in terms of you can have big impact using formal modeling with relatively less effort because a lot of good tools have been developed. And yet there's still a lot of low-hanging fruit, still a lot of opportunity to develop big insights with formal models in a way that there really isn't in some other fields like economics and finance. I'll just also say a couple of things about drawbacks and challenges of formal modeling. First of all, it does require some skills. There is entry barriers to being able to do formal models. It's helpful to have some mathematical aptitude, but that's not enough. You also need some training. Also, formal modeling is limited in the sense that you can only have so many moving parts in the formal model before it gets intractable. And this is my own personal challenge. I often start formal modeling projects with way too many moving parts and then wind up having to delete them out and take way too much time doing that. Hal Varian in his chapter, and I think it was eventually published as an article somewhere, he had this article called "How to Create an Economic Model in Your Spare Time." He suggests doing exactly the opposite of what I do, which is start as simple as possible and I think it's very wise advice, and I should follow it someday. Maybe I will before I retire. Also, formal modeling always sacrifices accuracy for the sake of simplicity and generality. There's always a trade-off between these three goals: accuracy, simplicity, and generality. No piece of research is ever going to achieve all three of those at the same time. And formal modeling is no exception to the need for trade-offs among those goals. Another problem that challenges me is sometimes I'll get results from a formal model and it's hard to explain what those results mean. What is the interpretation of them? What's the economic intuition behind them? And so that can be a challenge of doing formal modeling. It's not just, the challenge is not just doing the math. The challenge is also interpreting the math. And sometimes it's hard for me to interpret it to myself, much less to another person. And then accessibility. And I imagine that one of the other panelists will be talking about this in terms of an editor's point of view. But keeping a formal model accessible for your audience, translating it for non-technical audiences can be a big challenge too. And so you can ask yourself, is the juice worth the squeeze? Is it worth investing in formal modeling given these challenges? And the answer may be different for different people. So with that, I think I'm done, and I will pass it over to my fellow panelists.
Thank you very much, Rich, for an excellent presentation. By the way, it was like sharp on time, precisely.
Oh, really? I'm
Yes.
on time? I can't believe I'm on time. Okay.
Yeah, it was perfect. So thank you so much. And now again, we pass it to Claudio. Yeah, Claudio, please go ahead.
Yes, so thank you. So what I'll try to do actually is to build on Rich, because I agree with, let's say, 99% of what the things that he said, and I'm trying to build on some of his messages. I will devote some more time, maybe providing the same message, but with the perspective of trying to understand how to evaluate, how to think about formal models. And so what I'm trying to do, basically, if it moves, it's not moving. Okay, what I try to do, first of all, initial disclaimer, this is going to be a very highly non-technical presentation. There's going to be only one formula. I'm going to be talking about analytical models. So when I say models, I really mean analytical models, not computational models, for example. And this is for an audience made mostly by non-modelers, but if there is any modeler in the audience, I think you'll see the message also behind the many pictures that I will put there. And this is the time where, before I've coordinated with Olivier to give this presentation in the past. And back then I had to search the web to find for these pictures. Now we can rely on the E2 actually, and there's going to be at least a picture that I asked, I've been playing around and I finish all my credits with the software. So I'm going to show a few pictures that I took from there, which helps me a lot because I use a lot of pictures. So it makes my life much easier. In terms of the agenda, I'm going to basically split the presentation in two parts. So the first thing, building on what we just said, is going to be related to how to think about modeling. Okay, and the second one instead is more a discussion and talks that I'd like to share with you about how to evaluate formal models, and this will be then linked to what Olivier will have to say about his experience as an associate editor. So let me start with a sentence taken by this paper by Williamson, so maybe we can understand why we are thinking and talking about formal models. So good but underdeveloped ideas are evidently like good but underdeveloped minds. Both are precious things and are progressively built up, moving from less formal to more formal stages of development. And I think we can track this development if you look at many research projects, many fields that little by little have been moving, thinking about formalizing stuff. Well, if you take this seriously, then the question is, where do you stop? Okay, I'd like to make a short comparison with another very mathematical, intensive, heavy field, which is physics, just for a second, because this is going to help me to make a point about how to think about formal models. So in physics, if you go back to Galileo, he used to think about reality, as something, as the universe, as written in the language of mathematics. Okay, and if you think about what the greatest modeler ever had to say about the process of modeling, well, when thinking about how to move to reality here toward a theory, this is how Einstein was thinking about the process. So let's read it carefully. The following requirement for a complete theory seems to be a necessary one. Every element of the physical reality must have a counterpart in the physical theory. We believe that such theory is possible. But actually, for Einstein, eventually, there's going to be no difference between the theory and reality, because each and every single piece of reality should be accounted for in the model. This is very extreme. Okay, we are not in physics, so let's move to our field. Let's see the differences there, because it makes us think about how to evaluate models. So normally, what do you do with formal models? You postulate the existence of some agent that might be more or less rational, which can be individual agents, can be people, teams, organization, and you think about how they interact. So the key difference with respect to physical objects that are made of atoms is going to be that these agents we have in mind are diverse, they are socially influenced, they make mistakes, they have a purpose. A rock that is falling has no purpose. They act and they also learn in the process. So given that there are these differences between, this heavy hard science, which is physics, and our field, which is a little bit softer, which are the implications for these differences? So the first one, let me be very straight, is that the condition of completeness that I read before, the one by Einstein, well, you can forget about that. We are dealing with different reality that maybe is not even written all the time in the language of mathematics. So forget about conditional completeness for theory. Instead, most of the models, what we do in our field is to focus only on selected issues that we believe are of interest to us. Second, that is the way I want to talk about models. Forget about, for example, the management science approach in which you have inputs, you want to come up with an algorithm in which you put the inputs, and then you get as an outcome, as an output, a specific answer to a managerial problem. So that's not how I'm thinking about formal models, okay? And third, forget as a concept also about thinking about general theory. So Einstein was thinking about the general theory. Instead, we want to work only on partial mechanisms, okay? So this description basically speaks to a big change. This is also based on the book by Scott Page that I recently started reading again. So the approach that we just discussed with Einstein in physics is called the embodiment approach. Instead, in our field, we take another approach, which is called the analogy approach. So this is clearly stated in this SMJ paper by Salone in 91. So what's the purpose here in the analogy approach? Understanding why the results obtained, how the model works, is of primary interest. That understanding is what provides the insights, which are the final outputs of the endeavor. This is basically what Rich was saying. You know, it's not about the insight, it's not about precision. It's not about precision. It's really getting some specific insights that can help them to make sense of reality. And the aim here really it's metaphorical. So we do not want to depict reality. We just want to get a sense of a specific aspect that we think is relevant. So if you think about doing models, you have to understand that it's basically about making choices. Okay. So you want to understand, you want to focus on a specific feature of reality, you want to understand a specific problem. So it's mostly about making choices. And all the models have three characteristics. So first of all, they simplify. And let me also stress that they do not only simplify, you know, they can abstract from reality, they can distort reality, they can do terrible things to reality. They can even exaggerate reality because they think it's going to be like, how we can get an important message. So for example, if we look in art, the best example in art, I think it's Pablo Picasso, we know what he did. You know, he had this study of the bulls. Basically, this is a perfect example of abstraction and, you know, of distortion of reality, of exaggeration of reality. Because we are not artists, I mean, we want to do model, okay, let's look instead of, it's not working well. Let's look instead of an example of abstraction. So an example of an exaggeration instead in our field, which is the rationality assumption. This is the big elephant in the room. Sometimes this is not made explicit in the assumption that are set up in the model, but this is the big elephant in the room. This is an exaggeration of reality. And how does it look like? This sorry, I don't know, stop working. I will have to skip that. So this is an exaggeration because what we do is basically to assume that the brain of the economic agents making decision is huge. We're supposed to put a picture that is not showing that. So imagine a big brain there, you know, that's the exaggeration of reality that we do, for example, when we go for game theoretical analysis. We assume that agents are extremely rational. It's an exaggeration, and there is a reason why we take this exaggeration, and so we'll explain also later. So if the first characteristic of models that they simplify, okay, the example of Pablo Picasso. The second one is that they formalize selected features of interest. How do they do so? By basically using the language of mathematics. So if you think about this abstraction of Pablo Picasso himself, if you want to now formalize the model, you have to think about something like this. You come up with a description with formula that somehow, in the end, provides some representation of an economic agent, like this one, for example. Okay, so it's not about drawing, but it's about really representing reality using formulas. So if you want, you can think that a model, in the end, is a bunch of equations, and I will explain to which extent this is true. Keep in mind that also that the opposite is not true. It's not always the case that a bunch of equations is a model. So you can have just a bunch of equations, which is just a mathematical model, but that's not an economic model, because a model is made both of equation and interpretation of those equations and of the result. Okay, so this is the paper Rich was talking about. It was put in the chat. This is by Varian. And it is very useful because if we start thinking about formal models, we have a plan of attack, as Varian calls it. So these are basically the things that you want to do when thinking about formal models. So specifying what the people making the choices, which are the constraints that they face, how do they interact, and this speaks, the last point speaks to the game theoretical analysis, what adjusts if the choices are mutually consistent. Okay, so this is a plan of attack. It's a basic description for most of the models that you might think of in strategy. What I like to do is to talk a little bit more about the process behind coming up with people, constraints, and the like. Okay, so let's start with the plan of attack, okay, as given by Varian. And let's consider this messy rounded thing here in the middle of the picture as reality. What does it mean to make a model? Well, a model really, as I said before, is about simplifying and formalizing in order to get eventually to a mathematical representation of some feature of reality. Okay, so you jump over reality, taking with you some special features, and that's the first step. The second step, equally important, is that you understand, this goes back to the fact that a bunch of equations is not a model, is that once you have described reality with formulas, you have to solve the model, and this is where you come up with equilibrium concepts, Nash equilibrium, and the like, and you get the solution. So this X star comes out of solving this bunch of equations that we believe represent how people make decisions. Okay, let's be more specific about the process. So what does it mean to transform reality into a formal model? It's about making assumptions, making it simple, but how? Well, first of all, because we are talking about mathematics, we have to make mathematical assumptions. And that's mostly the case because we want to deal with a trackable model. Equally important, there is another set of assumptions which are more substantive that we think that describe reality and take into account specific aspects of reality. So if we take both the mathematical assumptions that are needed to solve the model and substantive assumption, and I will give an example, you come up with a formal model. It's basically made of functions, a description of decisions, the sequence of events, what you want to keep endogenous and exogenous, whether you think about the stochastic or the deterministic environment, is it static or dynamic, how do people behave, so are they rational, are they naive? If you put these things together, you basically come up with an artificial world. That's your creation, okay? You have the model, description of reality. And what is a model then? Then it's a structure in which then we can think logically. So what we are going to determine as a solution is thanks to formal proofs. Now, what do you do with this artificial world? Why is it useful? Let me provide first an example, and then we talk about why it's useful. So an example of substantive assumption. This is taken by my latest paper in AMR, in which, long story short, I try to study the functioning of teams. So what I do in that paper is to basically describe verbally the main assumption, if you want, the substantive assumption of the model. For example, just to focus on a few things, assumption one, I assume that teams consist of rational and identical self-interest members. That's a substantive assumption. I'm assuming that all the team members are equal. Another assumption here is about behavior, how to make decisions. And I'm assuming in the model that they make all the decisions independently and simultaneously. And then I assume that because there will be some dynamics, I postulate that these people might want to collaborate with that, they're willing to be cooperative from the beginning, unless somebody is deviating. Okay, so this is just an example of substantive assumption. To get to the model, what do you have to do? Well, transform those things into formulas, okay? Simple formulas if you want to come up with a closed form solution. The advantage that once you see the formula, you see all the limitations of the model. I could talk for 1 hour about the limitation of the models. There are many, but by the time you specify the substantive assumption and the mathematical assumption, then you know you have everything under control. You know the limitation of the model. So what can you do with this artificial world? Let me go back to two papers that explain the need and the usefulness of this artificial world. So this is a paper by Murthy, which is a marketing scholar, and back in the 90s was commenting on the fact that there were formal models coming in the marketing field. So this is how I comment on the need of artificial world. The researcher constructs an environment, a model, in which the actions to be explained take place, defining an artificial world with some connection to the real world, where it is easier to infer cause-effect relationship. In the words of Knudsen, Levinthal, and Puranam, this is a paper by a model, just a model, the relative advantages of a model and the disadvantages are the same of a verbal theorizing that a laboratory study has over analysis of field data. What one gives up in terms of realism, one gains in terms of the window into mechanism. So I think this is important for us to get a sense of how to think about formal models and which are the limitations and why they can be useful. So moving now toward the second part, which is about how to evaluate models. Well, as we said, models abstract and simplify. Okay, now if I want to go back to Simon, which was the initial statement in the presentation, taking another consideration that he had in one of his papers. So formalization is vital to a progressive research agenda, but it sometimes comes at a cost. Provision also needs to be made for the possibility that core features of the theory are left out or obscured by the translation. This is an important step. A model is a simplification. There is going to always be something which we are not taking into account. So look at this picture, for example. Suppose that this picture on top is reality. What the model does just focuses on something, okay, something that the researcher believes is important, but there is an advantage in doing so. So you see, the model is not able to depict reality, but there is an advantage of using for the model, which is the following one. So using always the word of Simon, the poverty of mathematics is an honest poverty that does not parade imaginary riches before the world. So you get to see what you're modeling, it's under control, you can understand the mechanism, okay? So it's all clear in front of your eyes. There is no speculation beyond what the model is actually allowing you to do. Now, there is another feature of models that I'd like to discuss. The first two, okay, we know the simplify, the formalize. There is a third one, which is very important. Let me be a little bit more provocative here, is that you have to understand that all the models are wrong. And so you should not trust any model. Why? Because you are abstracting from reality, you are focusing on specific features of reality, and you have to be aware of this. So let me discuss a little bit this problem. So we discussed how, you have a plan of attack, you want to land on a solid rock in which you have functional mathematical description of the model that you can solve. What you're tempted to do is to say, okay, now I have a solution, let me try to run back to reality and see how the results of the model apply to reality. Well, when you're doing this experiment, do not forget there is a bunch of equations that generated that solution, and that equation only limited ability to capture reality. So you have to be very careful when you try to move from the solution of the model to reality to try to make sense of that. And this speaks to a few critical issues that I'd like to discuss quickly, having to do with the role of assumptions and how to interpret the results, the solution of formal models. So an example, let's say that this is the reality we want to study. For whatever reasons, we want to see how dolphins behave and by interacting strategically over waves. What you have to do, we think about a model of economics, but we are able not to capture the behavior of dolphins, but only of cows. And we come up with an example with a formal model. Then based on the model, we solve it, and that's our solution. Okay, so you see the model is somehow depicting, some aspect of reality, but then if there is a reviewer seeing this, reading your paper, he might say, look, there is a problem here. The general engine of your theory simply doesn't ring true to me. Okay, you could agree, you could explain why this is the case or why it's not the case, but this is one of the problems you might find. A second one, let's suppose that our reality is now a giraffe. You say, look, I learned my lesson, working with economics is not good. Okay, let me go for another model in which I have to deform reality a little bit, I exaggerate reality. In the end, I can solve the model, but then you still have the reviewer saying, I'm also concerned that some of the assumptions that drive some of the results strains credulity. Well, they might be right, sometimes they are right, but let me read this sentence again by Knudsen, Levital, and Purana. The critical issue is not whether the model has some tight one-to-one mapping to the underlying context and phenomenon it is addressing, but whether the model, despite its limitations and distortions, captures some important fundamental properties of the underlying content. So again, the model is just a means for you to get some insight. You might exaggerate reality, but it's important then to understand what comes after the model and then to interpret that. Okay. Moving toward the end, because I'm running out of time, we also know that, when we think about how to evaluate model, we are all aware, that getting insights into reality cannot be only about modeling, but it also has to do with using other methodologies. So, so you have to triangulate across multiple research methods to get a sense of what's really happening in reality. So you have to think about formal models like any other methodology. There are advantages and there are disadvantages. This is something that we know. There is another aspect I'd like to emphasize. You do not have to think only about a single model, to make sense of reality. Sometimes you can use different models that are out there in the literature, so that you can put them together. And so by making this exercise of understanding the different implications of the model, putting them together, you can actually get a better understanding, okay? This is, again, there is a nice discussion about this in the book I mentioned before, The Model Thinker. So moving toward the conclusion, again, let me finish with the initial sentence. It's important to think about, even if you're thinking about your research idea, your research trajectory, that, this process of formalizing your research idea is an important one. It comes with a cost. As Rich was saying, you need to make an investment. It's not huge because in the end, we're talking about simple mathematics, but still, you have to make an investment, basic calculus, game theory, and the like. So, but if you make an investment, you're strong, you can move toward the direction of formalizing. You have to be creative because you don't want just to replicate existing models. You want to come up with new models. You have to be smart in solving the model. In the end, you can come up with your own world, and then you can start having fun trying to understand which are the implications of the model. And let me stop here. And sorry if I took a few extra minutes.
Thank you so much, Claudio. That was wonderful. I think we all feel so much cooler when we think that we are doing like a Matrix movie, when we are doing the modeling. And those pictures were really, those cows jumping out of water, I never thought about the papers that way, but I think we all appreciated that. Thank you so much. So now I pass it to Olivier, who will talk about the editor's perspective.
Yeah, that's because I'm still not mastering Zoom properly after all those years. So it's very nice to see familiar faces, but also familiar names in the audience. So a few of you have actually done for some time. So I salute you. So today the topic for this presentation is really the journal editor. So the journal editor. Who is the editor? Where do they live? What's their habitat? Do they have feelings? So we are going to answer some questions like this today. So the journal editor, you might think that there are semi-deities living on top of mountains, and then from time to time they send you thunderbolts, and you're terrified, okay, when you receive that. So I'm still trembling just thinking, okay, well, anyway, the reality is a bit different. The reality, I must break that to you, and it's based on all the things I learned during my spell as an editor, but thanks God I'm done with that. Nevertheless, I have things to share. The reality is a bit more like this. This is a true picture of a journal editor doing her or his job. So it's a typical day, and a typical day is a bad day at the office. Because you just ask for a review, and this is what happened. And you thought you would depend on this very nice assistant professor who's desperately trying to keep things together in their life. Of course, they just had surgery. Maybe they're almost dead, but they're like, yes, it's okay, but hope you're doing great. And you're like, oh, I'm so sad I'm destroying your life, and I appreciate the spirit. But still, I have to push that rock up the mountain. So the journal editor, the habitat is really pushing the rock up the mountain, and it's not necessarily fun. But there are a lot of insights that I think are relevant, not only for formal models, but a lot of that I think is quite useful for any kind of publishing in our field, but I will try to highlight what's also special for journal editors. So this is the process for which your paper is going through. You submit it. Then there's a first question, which is this going to be a desk reject? Then there's going to be an associate editor selection that's done by usually a senior editor. The associate editor will select referees, which will produce in the end a decision that's going to be made by the associate editor. So in our top journals, the reject is probably at least 90% of the time. But by the way, you're like opening a bottle of champagne when you accept a paper, because it never happens. There's an unknown number of reject and resubmits. Let's say that revise and resubmit, maybe it's about 10%. So these are like a priori statistics. And if you have an R&R, you're more likely than not, I would say, to get a conditional accept. But it's not like, it's still not done. Okay, so let's look at the beginning of this process. And there are 3 questions. Okay, what can go wrong? What's in the mind of the editor? Because the editor, they have feelings and hopes and aspirations. And then what's specific, if anything, about formal models. Yeah. So let's look at the first part of the project, the process. So what can go wrong? A death reject is one thing that can go wrong. Actually, sometimes actually a good thing that may happen. And usually it's because the paper is not deemed readable for the audience of a journal. So it could be a topic mismatch. It could be that we don't understand why we're doing this, and we don't want to waste anyone's time. Right? Another thing that can go wrong is that you might get an associate editor who may not be that familiar with the methods of the topic, because what you're sending may be quite specialized. And then, although they might be very well-meaning, they may also be less prone to take a really active role in shaping the R&R, and that's not gonna help you. So what's in the mind of the editor? Let's say the associate editor. Now, first, the editor-in-chief, they have an editorial line. So they think about the audience of the journal, they think of the mission of the journal. And there are 2 missions. One is science, where to drive the field, but there's also a less obvious, but actually that's something is in the mind of the editor. They want to boost the field so that people eventually get tenure. And because there's competition between fields at university levels, and journals matter for that. So you have to be vaguely aware of that political economy of fields and competition for resources in universities. I mean, not that it really is going to change much when you submit, but that's something that you should never forget about. So what's specific about formal papers? So you are going to get dinged immediately or get the wrong AE, because the AE is less likely to be a specialist of formal models. So if your paper does not make sense to a non-specialist, because of research question, because of the fluent presentation, you can get a bad match between your paper and who's going to be the AE, and eventually who's going to be your referees. So that's something you have to be very, very careful about. I'm going to go back to that a few more times. Now, let's get to the next step, which is referee selection. Okay, what can go wrong? You're going to get possibly referees that are not very engaged. So they are not very excited by the paper. So to some extent, sometimes it's better to have someone who reacts a bit negatively to the paper, but is really into it, than someone who's detached. Because if the paper, someone who's slightly negative, but really interested or reacting like very annoyed sometimes, it still means that they care. So that's something that you can work with. You can also have referees who just don't understand what you're doing and why. So that means that they don't have the absorptive capacity, they're not equipped to really pick up what you think matters in the paper. So that's something that can go wrong. And for the editor, they have other concerns. So the first concern, I alluded to that with pushing the rock of the mountain before it falls down, is that, I mean, by the end, it's gotten really worse, but by the end of my time as an associate editor, I was getting to sign up 2 referees. Sometimes I needed to try 4 or even 5 times to get someone. So by the time you are at person number 5, it's not 100% likely it's going to be your first choice in terms of fit. Yeah. So finding referees that can give good evaluation and that are relevant, it's hard because there are not that many of them. So because of that, that's something that I really understood that actually even only after a few years on that particular job, is that a lot of the weird things that may be happening from from the author viewpoint in the process is that the editor, they actually need to keep the regular referees happy, because there's going to be another paper to review. So you might be playing like a one-shot game with the referee, but the editor is not. And that's sometimes that's going to bring some pathologies, or that's going to explain some behavior that you may think is a bit strange. But you have to keep in mind that there's a relationship between the editor and the referee, not that they're colluding with each other, not that they are friends and they want to help each other, but more that the editor needs to keep referee on their side. And that means that you need to help the editor do that. Not by agreeing with everything what they do, but you have to be a bit strategic about how you treat them. So what's specific about formal papers in that in that world is that there's an even more limited pool of referees. So maybe it's good, maybe it's bad. So it can be good because sometimes you're reading the comments and you're like, oh, I know this is so and so because this is exactly the way she speaks in conferences. Okay, and sometimes not. But then if you're part of the club, it helps. Now, some difficulty is that there's a variety of opinions about how to package papers. Do you want to have something that's more flowing and more like propositions in language? But some people will say, no, proposition, that should be like math with a lot of symbols. Yeah? And the last thing is that you're very likely to get some non-formal method referees that are because of the topic you picked. And sometimes they may be distracted by the methods. Not that they cannot comprehend it, but they may not understand exactly why you do things. And so there's a communication problem there. Okay, so these are the problems that may show up at referee selection. Now let's look at the decision. So what can go wrong? Maybe the reviews are short, curt, not so good. Maybe they are late, maybe they are both. So by the way, if you want to, as a referee, at least that's my viewpoint, but I don't know about what other people could say around that virtual table, is that I'd rather you be late, but if you're going to be late, please tell me what your next deadline is going to be, and please respect that one. Because what I would be scared of as an editor is that someone is late and disappears. So it's better to be late by informing, look, dear editor, I need 2 more weeks, but then do it. And as opposed to disappear. So being late is okay-ish, but being reliable, even if you're late, is really the most important thing. Precisely because there's a scarcity of referees. And I see Rich is like 2 thumbs up. If you must be late, please be on time with your new deadlines or something like this. Something that is difficult is when reviews are not constructive, which may happen, or they're not consistent with each other, and you cannot satisfy everyone. So what's in the mind of the editor? So the editor, I mean, they would love to publish more papers because it so rarely happens. So the question they're going to ask themselves is, okay, given these reviews, given my own evaluation, what can I see? Can I help them craft, them being the authors? Can I see a path to publishable papers? Okay, maybe how much do I need or want to annoy some referees if I must? Okay? Because that's something that you want to do sometimes, because there's value to doing that. What you don't want is a rejection after an R&R, especially if you feel that the authors did a bad job at revising. Because if you do a bad job at revising, everyone feels they wasted their time, and then your referee is actually very annoyed. It's like, come on, why did you give an R&R? Because these authors are obviously unable to even try to do something well. Okay, so what you have to think about as an editor is, what's my threshold for granting possibly a conditional accept next round? Because that's what I'm going to try to shoot for, at least be close to. Then to do that, is it worth placing a bet on the authors? And something about placing a bet is not just the paper. It's like, well, okay, the paper may not be perfect, but can I hope that the authors are going to seize this opportunity? Because I'm lending them time with referees later, and I don't want that time to be totally wasted, precisely because the referees are the scarce part in the process. So sometimes this is why you get to reject and resubmit. That's the get out of jail free card for the editors. Like, well, I don't know what to do. There's something, but I'd rather not go in a fishing expedition. Yeah. So what's specific about formal models in that situation is that, especially for a new author, it can be hard for you to signal that you can, at the same time, write a paper that fits with an important strategic question that is technically sound. Because if I feel that the question is good, but you don't know how to do a model, I'm less likely to give you an R&R, okay? Because I'm very afraid that you're going to screw up the opportunity. So you have to convince me that you can size the opportunity, because that opportunity is costly for the editor to give. And it is costly to give because it relies on taking more time from referees whose time is scarce and also valuable. All right, you're at the revise and resubmit stage, maybe conditional accept. That's great news. Again, what can go wrong? You revise the paper, but there's no tangible progress. I look at the revision, I look at the response letters. All right, this is terrible. I don't know if they're going to be able to turn this around another time. Or another thing that's something that happened to me a couple of times as an author is that you painted yourself in a corner, is that you try to accommodate everyone, but in the end, you're putting yourself in a contradictory situation. That's something I learned the very hard way, is that usually you don't want to push back too much on the referees, but sometimes you must do it, because if you don't do it, then you back yourself in a corner and you're going to lose regardless. So at this point, what's in the mind of the editor? As an editor, regardless of the outcome, so what you like to see is that the authors are really engaging intellectually and in good faith with the referees. Me, just like everyone here, I hate reading reviews of my papers. Okay, I'm like, this is so unfair. And like, but at the same time, you have to start from a position that if they don't understand or don't like what you do, it means that you could do it better, and there's something to learn there. Okay, so as editors, they want good papers that make them feel better. And so the question about the progress is the paper becoming more interesting? Is it more appropriate to the journal? And especially, is the contribution better explained? If all that is yes, then yeah, okay, we'll give you an R&R, maybe there's another one, and it's moving in the right direction. If there's some stasis or it's going nowhere, then you're really in a dangerous situation. So a couple of things about formal paper that always show up is how to defend some of your assumptions. Because I think Claudio talked a lot about that. That was also underlying a lot of what Rich was saying. So basically, you have two options. Either you say, oh, the assumption you don't like doesn't matter, or B, the assumption you like, yes, it does matter, but it's deliberate, and there's a good reason. So sometimes option one leads you to have a 20-page appendix with, oh, if we don't do that, then everything like this happens. And you know, in the end, 90% of the time, it's still the same thing. So please, please, please get off my back. I've done that where the appendix is equation that are longer than the paper. Option two is like, no. Yes, I know it seems absurd. There's a reason for that. And the reason is that I have a good trade-off in terms of, I don't know, simplicity and insight that is deliberate. And then you stand your ground, but you try to really be pedagogical about it and to really argue why you must do it and why actually it's a good trade-off. And that's something that's sometimes easier to explain in a letter than in the paper. All right, I'm almost done. So stepping back, there are a few implications especially for those who start new projects. So if you're at the stage of project inception, the criteria is that your research question and motivation for the project, it always must make sense and matter to non-formal theorist audience. It must matter to people who are your median colleagues. So the median researcher in our field, your median colleague, your median committee member, they are not formal modelers. Okay, but what you do and why should make sense to them. So again, what is the problem you're trying to deal with? It must be in the strategy literature or stemming from that. And there's still a lot of low-hanging fruits, as Rich mentioned earlier. Why does it matter to you as non-specialist colleague? Why is it that solving that is good for you? And then there's something that's a bit hard is why solving it with formal method is a good idea. Why is it a good idea? And basically what you want to say is a payoff of using formal methods, and also there's a payoff for using that particular formal method. Why does it matter? Because it's always a challenge to explain why the specific method and the approach fits the problem. That's something that we've seen in all these three presentations. There's one common mistake, which is that, oh, I have a great method, and when I try to look for an application, that's like, I just found a hammer, so where are the nails? And usually that's going to be bad, because people are like, yeah, you're using a hammer, but you know what? I have this nice wrench, and I don't care about your hammer. And common mistake number two is when, and you see that with formal model, but even more so, I would say, with some simulations, is that you have a model that is in search of a question. Oh, I found this weird result, so can I retrofit the motivation to the model? And that's very hard to do. And so be careful about that, because a reader will see it. Will say, oh, it's very clear that your front end makes no sense because you don't really you had the results first, and then you try to explain why they matter, but that doesn't work that well. And there's the same thing because something that we always do when we have empirical research is that at one point you're being told that, well, you know what you're actually doing when you run your regression is not testing actually the theory you thought you were doing. So this type of mismatch between motivation and method is not specific to formal models, but that's something that you should also be aware of. So to sum up, let me repeat that again. The research question should fit the journal and the audience. You have two audiences with very different expectations and very different absorptive capacity. You have the topic experts, so they care about, can you change the theory for them to think better about what they do, but they're mostly empiricists, I would say. And you have the modelers, and they care about what you do technically because they think it matters, okay? So even if you do something technical, you should demonstrate relevance to some question that matters to non-modelers. Always remember that referees are the scarce resource in the process, so if only that can make you a bit more. So I know referees are annoying. I'm sure I'm the most annoying referee in the world, but they are the scarce resource in the process, so you want to be positive about that in some way. So how to improve your odds? Help the editors help you, okay? Always mention, oh, but maybe that paper would fit with this associate editor, these potential referees. You know, and really show that you're genuinely trying to learn the process and that you're respectful of the referee and the editor team. Even if someone acts in what you perceive as being very annoying, it basically means that, well, there's a communication problem, and it's incumbent on you to deal with that and show you that you care about contributing to the field, that you're not just, you know, playing the game and trying to get more things out. That's going to be actually the way to get more things out. I think that's all I have for this one here.
Yeah, thank you very much, Olivier. So now we know that editors also have feelings, right?
Sometimes, not all of them.
So again, thank you very much, Rich, Olivier. So I think Claudio apparently has some big Wi-Fi connection problems. So hopefully he can rejoin us.
I managed to rejoin just for the conclusions. So
perfect.
It's a problem with the building. It's not my problem.
Yeah, well, okay. Glad to have you for the Q&A part. So before we get to Q&A, I would actually like to do a little screenshot for the posterity. So if you don't mind, please turn the video on so we can have a nice picture. You know, it goes on Twitter, so it will be there forever, I guess. Okay, so you guys seen people. So I guess please smile and say formal modeling.
Modeling. Oh, modeling.
Okay, I think I got one, so I think we are good. But please, keep on the cameras if you can, then because then it's nicer for the Q&A, right? So let me see, and I don't know if we have some specific questions in the chat. So let me see. Okay, I guess people are still thinking about their next big question. So maybe while they're doing that, I actually want to maybe kick it off and ask a very unfair question. But if you wouldn't mind, in your experience of, publishing formal models, what could you share some, like, the biggest hurdle that you have encountered, the worst experience and kind of how you overcame that could be, potential example to everybody else?
Well, I mean, I can remember times where we had to kind of completely restructure the model. For me, the biggest challenges are the things I said. One is keeping it simple enough, and two is interpreting the results.
Okay, I guess I should say something too. I think the hardest thing I've done, but that's something that I don't recommend doing at all, and there's only a narrow period of time where that may happen in your career, is when I did not follow up on an R&R because I felt I was set up for failure and I was under heavy pressure, so I had to send the paper to a different journal where I felt I was less likely to be set up for failure. But that's very, very unusual. And although the work I did to realize that I was being backed into a corner, that was very useful for the next submission. So that was helpful later on, but I don't recommend doing that in general. It was very, very unusual. And that actually involved, to be fair, totally redoing the paper. And the new version was stemmed out of the version where I withdrew because it was doomed. And if it did not work out, I would not have the time to resubmit somewhere else. And I had a clock problem.
For me, the biggest problem is always to identify the right audience. Am I talking to Olivier? Am I talking to Rich? So a very small niche of people doing formal models, or am I talking to the broader audience? And that's tricky because it really depends on the reviewers that you get. And then they can help you a lot in framing the paper and making sure you're talking to a broader audience, or they can just give the paper. It depends.
Thank you very much. So I think Joao has a question. So Joao, please unmute yourself and go ahead. And the rest of you, same, like if you want, you can raise your hand or type in the chat.
All right. First of all, thank you all for the presentation, for the lecture. I have a question that is that caught my attention on Dr. Makadok's presentation, but I think it's useful for all of us. I'm actually in the entrepreneurship field, by the way. I'm Dr. Klein's advisee at Baylor.
Oh, Peter, I said hi.
Yeah, I will. And I think especially for us in the beginning of the journey, the first question would be, where should we start? And not only when should we start, and how should we start, especially thinking about the entrepreneurship field and thinking about how to, how to put the role of the entrepreneur inside of supply and demand curves. It's not easy. It's not an easy task. And so how can we contribute to the field, not only this particular field, but any other fields? How can we contribute to the fields, knowing the limitations of our contributions, but even still making solid contributions within our fields? I think this is the big question. Like the first steps, at least to me, the first step is always the hardest step to take. So especially for the ones that are starting the journey right now, what should be like the pro tips from starting?
I would say find a puzzle, find something that, some puzzle or problem that, some phenomenon out there that doesn't make sense from the perspective of existing theory. And then, think about what new features would have to be added to the theory in order for that phenomenon to make sense. And often a formal model can help with that.
Yeah, adding to that, maybe reformulating it a bit differently, that sometimes find something where you think that, but the people who write this, it's wrong. They're totally missing this thing. That must be important. And having a formal model is a good way of actually going to the logical conclusion from, well, that assumption they make implicitly is really wrong. And because if I put that in the model, then the consequences are really tangible. That's another way to, maybe it's not a stronger than a puzzle. If you have an emotional reaction like, oh, that must be wrong, that can't be right, that's a good motivation.
Yeah, if I can add, there are many things that have been studied using formal models. The problem, they can actually speak to the problem of being an entrepreneur. Cooperation, coordination, provision of incentive, incomplete contracts, dealing with uncertainty. There is just a huge population of models. So then you can think about which is the phenomenon that these models are studying that could be relevant for entrepreneurship, and are there specific assumptions of this model that do not reflect the problem of entrepreneurship. So you can take whatever family of formal models you think are relevant for general problems, and then try to somehow calibrate these models to inject a little bit of reality into them. Reality that comes from entrepreneurship and all the problems related to the specific setting. So move from the formal model that already exists to speak about general problem and see how to adjust them to understand something specific about entrepreneurship. That would be my suggestion.
Thank you again. Thank you very much, Rich, Olivier, and Claudio. So at this point, it's like 12:20 p.m. So I would suggest that at this point, we stop the recording. So the official panel is over.